Suggestions will filter as you type. Suggestions will filter as you type. 1100 XP. Secure a data warehouse in Azure Synapse Analytics. 55 minutes. Module. 10 units. Intermediate. Data Engineer. Azure Synapse Analytics. Learn how to approach and implement security to protect your data with Azure Synapse Analytics. Learning objectives. In this module, you will understand network security options for Azure Synapse Analytics, configure conditional access, configure authentication, manage authorization through column and row level security, manage sensitive data with dynamic data masking, implement encryption in Azure Synapse Analytics. Prerequisites. Before taking Introduction. In this module, you will learn how to approach and implement security to protect your data with Azure Synapse Analytics. In this module, you will understand network security options for Azure Synapse Analytics, configure conditional access, configure authentication, manage authorization through column and row level security, manage sensitive data with dynamic data masking, implement encryption in Azure Synapse Analytics, understand advanced data security options for Azure Synapse Analytics. Prerequisites. Before taking this module, it is recommended that the student is able to log into the Azure portal, create a Synapse Analytics workspace, create an Azure Synapse Analytics SQL pool. Next unit, understand network security options for Azure Synapse Analytics. Continue. Need help? CR. Continue. Need help? Understand network security options for Azure Synapse Analytics. Completed 100 XP. 5 minutes. There are a range of network security steps that you should consider to secure Azure Synapse Analytics. One of the first aspects that you will consider is securing access to the service itself. This can be achieved by creating the following network objects, including firewall rules, virtual networks, private endpoints, firewall rules. Firewall rules enable you to define the type of traffic that is allowed or denied access to an Azure Synapse workspace using the originating IP address of the client that is trying to access the Azure Synapse workspace. IP firewall rules configured at the workspace level apply to all public endpoints of the workspace, including dedicated SQL pools, serverless SQL pool, and the development endpoint. You can choose to allow connections from all IP addresses as you are creating the Azure Synapse workspaces, although this is not recommended as it does not allow for control access to the workspace. Instead, within the Azure portal, you can configure specific IP address ranges and associate them with a rule name so that you have greater control. Make sure that the firewall on your network and local computer allows outgoing communication on TCP ports 80, 443 and 1443 for Synapse Studio. Also, you need to allow outgoing communication on UDP port 53 for Synapse Studio. To connect using tools such as SSMS and Power BI, you must allow outgoing communication on TCP port 1433. Virtual networks. Azure Virtual Network, VNet, enables private networks in Azure. VNet enables many types of Azure resources, such as Azure Synapse Analytics, to securely communicate with other virtual networks, the Internet, and on-premises networks. When you create your Azure Synapse workspace, you can choose to associate it to a Microsoft Azure Virtual Network. The virtual network associated with your workspace is managed by Azure Synapse. This virtual network is called a Managed Workspace Virtual Network. Using a Managed Workspace Virtual Network provides the following benefits. With a Managed Workspace Virtual Network, you can offload the burden of managing the virtual network to Azure Synapse. You don't have to configure inbound NSG rules on your own virtual networks to allow Azure Synapse management traffic to enter your virtual network. Misconfiguration of these NSG rules causes service disruption for customers. You don't need to create a subnet for your Spark clusters based on peak load. Managed Workspace Virtual Network along with managed private endpoints protects against data exfiltration. You can only create managed private endpoints in a workspace that has a Managed Workspace Virtual Network associated with it. It ensures that your workspace is network isolated from other workspaces. If your workspace has a Managed Workspace Virtual Network, data integration and Spark resources are deployed in it. A Managed Workspace Virtual Network also provides user-level isolation for Spark activities because each Spark cluster is in its own subnet. Dedicated SQL Pool and Serverless SQL Pool are multi-tenant capabilities and therefore reside outside of the Managed Workspace Virtual Network. Intra-workspace communication to Dedicated SQL Pool and Serverless SQL Pool use Azure Private Links. These private links are automatically created for you when you create a workspace with a Managed Workspace Virtual Network associated to it. You can only choose to enable Managed Virtual Networks as you are creating the Azure Synapse workspaces. Private endpoints. Azure Synapse Analytics enables you to connect up its various components through endpoints. You can set up managed private endpoints to access these components in a secure manner known as private links. This can only be achieved in an Azure Synapse workspace with a managed workspace virtual network. Private link enables you to access Azure services, such as Azure Storage and Azure Cosmos DB, and Azure hosted customer/partner services from your Azure virtual network securely. When you use a private link, traffic between your virtual network and workspace traverses entirely over the Microsoft backbone network. Private link protects against data exfiltration risks. You establish a private link to a resource by creating a private endpoint. Private endpoint uses a private IP address from your virtual network to effectively bring the service into your virtual network. Private endpoints are mapped to a specific resource in Azure and not the entire service. Customers can limit connectivity to a specific resource approved by their organization. You can manage the private endpoints in the Azure Synapse Studio Manage Hub. Next unit, configure conditional access. Continue. Need help? See our troubleshooting guide or provide specific. Continue. Need help? See our troubleshooting guide or configure conditional access. Completed 100 XP. 7 minutes. Conditional access is a feature that enables you to define the conditions under which a user can connect to your Azure subscription and access services. Conditional access provides an additional layer of security that can be used in combination with authentication to strengthen the security access to your network. Conditional access policies at their simplest are if-then statements. If a user wants to access a resource, then they must complete an action. As an example, if a data engineer wishes to access services in Azure Synapse Analytics, they may be requested by the conditional access policy to perform an additional step of multi-factor authentication, MFA, to complete the authentication to get onto the service. Conditional access policies use signals as a basis to determine if conditional access should first be applied. Common signals include user or group membership names, IP address information, device platforms or type, application access requests, real-time and calculated risk detection, Microsoft Cloud App Security, MCAS. Based on these signals, you can then choose to block access. The alternative is you can grant access, and at the same time request that the user perform an additional action including perform multi-factor authentication. Use a specific device to connect. Given the amount of data that could potentially be stored, Azure Synapse Analytics dedicated SQL pools supports conditional access to provide protection for your data. It does require that Azure Synapse Analytics is configured to support Microsoft Entra ID, and that if you chose multi-factor authentication, that the tool you are using support it. To configure conditional access, you can perform the following steps. Sign into the Azure portal, select Microsoft Entra ID, and then select Conditional Access. In the Conditional Access Policies blade, click New Policy, provide a name, and then click Configure Rules. Under Assignments, select Users and Groups, check Select Users and Groups, and then select the user or group for conditional access. Click Select, and then click Done to accept your selection. Select Cloud Apps, click Select Apps. You see all apps available for conditional access. Select Azure SQL Database, at the bottom click Select, and then click Done. If you can't find Azure SQL Database listed in the following third screenshot, complete the following steps. Connect to your database in Azure SQL Database by using SSMS with a Microsoft Entra admin account. Execute Create user@yertnet.com, from external provider. Sign into Microsoft Entra ID and verify that Azure SQL Database, SQL Managed Instance, or Azure Synapse are listed in the applications in your Microsoft Entra instance. Select Access Controls, select Grant, and then check the policy you want to apply. For this example, we select Require Multi-Factor Authentication. Next unit, Configure Authentication. Continue. Need help? See our troubleshooting guide or provide specific feedback. Configure Authentication. Completed 100 XP. 8 minutes. Authentication is the process of validating credentials as you access resources in a digital infrastructure. This ensures that you can validate that an individual, or a service that wants to access a service in your environment can prove who they are. Azure Synapse Analytics provides several different methods for authentication. What needs to be authenticated? There are a variety of scenarios that means that authentication must take place to protect the data that is stored in your Azure Synapse Analytics estate. The common form of authentication is that of individuals who want to access the data in the service. This is typically seen as an individual providing a username and password to authenticate against a service. However, this is also becoming more sophisticated with authentication requests working in combination with conditional access policies to further secure the authentication process with additional security steps. What is less obvious is the fact that services must authenticate with other services so that they can operate seamlessly. An example of this is using an Azure Synapse Spark or serverless SQL pool to access data in an Azure Data Lake store. An authentication mechanism must take place in the background to ensure that Azure Synapse Analytics can access the data in the data lake in an authenticated manner. Finally, there are situations where users and services operate together at the same time. Here you have a combination of both user and service authentication taking place under the hood to ensure that the user is getting access to the data seamlessly. An example of this is using Power BI to view reports in a dashboard that is being serviced by a dedicated SQL pool. Here you have multiple levels of authentication taking place that needs to be managed. Types of security. The following are the types of authentication that you should be aware of when working with Azure Synapse Analytics. Microsoft Entra ID. Microsoft Entra ID is a directory service that allows you to centrally maintain objects that can be secured. The objects can include user accounts and computer accounts. An employee of an organization will typically have a user account that represents them in the organization's Microsoft Entra tenant, and they then use the user account with a password to authenticate against other resources that are stored within the directory using a process known as single sign-on. The power of Microsoft Entra ID is that they only have to log in once, and Microsoft Entra ID will manage access to other resources based on the information held within it using pass-through authentication. If a user and an instance of Azure Synapse Analytics are part of the same Microsoft Entra ID, it is possible for the user to access Azure Synapse Analytics without an apparent login. If managed correctly, this process is seamless as the administrator would have given the user authorization to access Azure Synapse Analytics dedicated SQL pool as an example. In this situation, it is normal for an Azure administrator to create the user accounts and assign them to the appropriate roles and groups in Microsoft Entra Idaho. The data engineer will then add the user, or a group to which the user belongs to access a dedicated SQL pool. Managed identities. Managed identity for Azure resources is a feature of Microsoft Entra ID. The feature provides Azure services with an automatically managed identity in Microsoft Entra Idaho. You can use the managed identity capability to authenticate to any service that supports Microsoft Entra authentication. Managed identities for Azure resources are the new name for the service formerly known as Managed Service Identity, MSI. A system-assigned managed identity is created for your Azure Synapse workspace when you create the workspace. Azure Synapse also uses the managed identity to integrate pipelines. The managed identity lifecycle is directly tied to the Azure Synapse workspace. If you delete the Azure Synapse workspace, then the managed identity is also cleaned up. The workspace managed identity needs permissions to perform operations in the pipelines. You can use the object ID or your Azure Synapse workspace name to find the managed identity when granting permissions. You can retrieve the managed identity in the Azure portal. Open your Azure Synapse workspace in Azure portal and select Overview from the left navigation. The managed identity's object ID is displayed in the main screen. The managed identity information will also show up when you create a linked service that supports managed identity authentication from Azure Synapse Studio. Launch Azure Synapse Studio and select the Manage tab from the left navigation. Then select Link Services and choose the plus New option to create a new link service. In the new link service window, type Azure Data Lake Storage Gen 2. Select the Azure Data Lake Storage Gen 2 resource type from the list below and choose Continue. In the next window, choose Managed Identity for Authentication Method. You'll see the managed identity's name and object ID. SQL Authentication. For user accounts that are not part of a Microsoft Entra ID, then using SQL authentication will be an alternative. In this instance, a user is created in the instance of a dedicated SQL pool. If the user in question requires administrator access, then the details of the user are held in the master database. If administrator access is not required, you can create a user in a specific database. A user then connects directly to the Azure Synapse Analytics dedicated SQL pool where they are prompted to use a username and password to access the service. This approach is typically useful for external users who need to access the data, or if you are using third-party or legacy applications against the Azure Synapse Analytics dedicated SQL pool. Multi-factor authentication. Synapse SQL support connections from SQL Server Management Studio, SSMS, using Active Directory Universal Authentication. This enables you to operate in environments that use conditional access policies that enforce multi-factor authentication as part of the policy. Keys. If you are unable to use a managed identity to access resources such as Azure Data Lake, then you can use storage account keys and shared access signatures. With a storage account key, Azure creates two of these keys, primary and secondary, for each storage account you create. The keys give access to everything in the account. You'll find the storage account keys in the Azure portal view of the storage account. Just select Settings, and then click Access Keys. As a best practice, you shouldn't share storage account keys, and you can use Azure Key Vault to manage and secure the keys. Azure Key Vault is a secret store, A centralized cloud service for storing app secrets, configuration values like passwords and connection strings that must remain secure at all times. Key Vault helps you control your app's secrets by keeping them in a single central location and providing secure access, permissions control, and access logging. The main benefits of using Key Vault are separation of sensitive app information from other configuration and code, reducing risk of accidental leaks. Restricted secret access with access policies tailored to the apps and individuals that need them. Centralized secret storage, allowing required changes to happen in only one place. Access logging and monitoring to help you understand how and when secrets are accessed. Secrets are stored in individual vaults, which are Azure resources used to group secrets together. Secret access and vault management is accomplished via a REST API, which is also supported by all of the Azure management tools as well as client libraries available for many popular languages. Every vault has a unique URL where its API is hosted. Shared access signatures. If an external third-party application needs access to your data, you'll need to secure their connections without using storage account keys. For untrusted clients, use a shared access signature, SAS. A shared access signature is a string that contains a security token that can be attached to a URI. Use a shared access signature to delegate access to storage objects and specify constraints, such as the permissions and the time range of access. You can give a customer a shared access signature token. Types of shared access signatures. You can use a service-level shared access signature to allow access to specific resources in a storage account. You'd use this type of shared access signature, for example, to allow an app to retrieve a list of files in a file system or to download a file. Use an account-level shared access signature to allow access to anything that a service-level shared access signature can allow, plus additional resources and abilities. For example, you can use an account-level shared access signature to allow the ability to create file systems. Next unit, manage authorization through column and row level security. Continue. Need help? See our trouble. Manage authorization through column and row level security. Completed 100 XP. 6 minutes. In this topic, we'll go through how you can manage authorization through column and row level security within Azure Synapse Analytics. We'll start off by talking about column level security in Azure Synapse Analytics, and finish with row level security. Column level security in Azure Synapse Analytics. Generally speaking, column level security is simplifying a design and coding for the security in your application. It allows you to restrict column access in order to protect sensitive data. For example, if you want to ensure that a specific user Leo can only access certain columns of a table because he's in a specific department, the logic for Leo only to access the columns specified for the department he works in is a logic that is located in the database tier, rather than on the application level data tier. If he needs to access data from any tier, the database should apply the access restriction every time he tries to access data from another tier. The reason for doing so is to make sure that your security is reliable and robust, since we're reducing the surface area of the overall security system. Column level security will also eliminate the necessity for the introduction of view, where you would filter out columns, to impose access restrictions on Leo. The way to implement column level security is by using the grant T-SQL statement. Using this statement, SQL and Microsoft Entra ID support the authentication. Syntax. The syntax to use for implementing column level security looks as follows. Grant permission, n, on, object, schema underscore name. Object underscore name, column, n, / specifying the column access to database. So when would you use column level security? Let's say that you are a financial services firm, and can only have an account manager allowed to have access to a customer's social security number, phone number, or other personally identifiable information. It is imperative to distinguish the role of an account manager versus the manager of the account managers. Another use case might be related to the healthcare industry. Let's say you have a specific healthcare provider. This healthcare provider only wants doctors and nurses to be able to access medical records. The billing department should not have access to view this data. Column level security might be the option to use. So how does column level security distinguishes from row level security? Let's look into that. Row level security in Azure Synapse Analytics. Row level security, RLS, can help you to create a group membership or execution context in order to control not just columns in a database table, but actually, the rows. RLS, just like column level security, can simply help and enable your design and coding of your application security. However, compared to column level security where it's focused on the columns, parameters, RLS helps you implement restrictions on data row access. Let's say that your employee can only access rows of data that are important to the department. You should implement RLS. If you want to restrict, for example, Customer data access that is only relevant to the company. You can implement RLS. The restriction on the access of the rows is a logic that is located in the database tier, rather than on the application level data tier. If Leo needs to access data from any tier, the database should apply the access restriction every time he tries to access data from another tier. The reason for doing so is to make sure that your security is reliable and robust, since we're reducing the surface area of the overall security system. The way to implement RLS is by using the create security policy. Include SQL statement. The predicates are created as inline table valued functions. It is imperative to understand that within Azure Synapse, only supports filter predicates. If you need to use a block predicate, you won't be able to find support at this moment within Azure Synapse. Description of row-level security in relation to filter predicates. RLS within Azure Synapse supports one type of security predicates, which are filter predicates, not block predicates. What filter predicates do, is silently filtering the rows that are available for reading operations such as select, update, delete. The access to row-level data in a table is restricted as an inline table-valued function, which is a security predicate. This table-valued function will then be invoked and enforced by the security policy that you need. An application is not aware of rows that are filtered from the result set for filter predicates. So what will happen is that if all rows are filtered, a null set is returned. When you are using filter predicates, it will be applied when data is read from the base table. The filter predicate affects all get operations such as select, delete, update. You are unable to select or delete rows that have been filtered. It is not possible for you to update a row that has been filtered. What you can do, is update rows in a way that they will be filtered afterward. Use cases. We've already mentioned some use cases for RLS. Another use case might where you have created a multi-tenant application where you create a policy where logical separations of a tenant's data rows from another tenant's data rows are enforced. In order to implement this efficiently, it is highly recommended to store data for many tenants in a single table. When we look at RLS filter predicates, they are functionally equivalent to a pending a where clause. The predicate can be as sophisticated as business practices dictate, or the clause can be as simple as where tenant equals 42. When we look at RLS more formally, RLS introduces predicate-based access control. The reason why RLS can be used for predicate access control is that it is a flexible, centralized, predicate-based evaluation. The filter predicate can be based on metadata or any other criteria you would determine as appropriate. The predicate is used as a criterion to determine if the user has the appropriate access to the data based on user attributes. Label-based access control can be implemented by using predicate-based access control. Permissions. If you want to create, alter or drop the security policies, you would have to use the alter any security policy permission. The reason for that is when you are creating or dropping a security policy, it requires alter permissions on the schema. In addition to that, there are other permissions required for each predicate that you would add. Select and references permissions on the inline table valued function being used as a predicate. References permission on the table that you target to be bound to the policy. References permission on every column from the target table used as arguments. Once you've set up the security policies, they will apply to all the users, including DBO users in the database. Even though DBO users can alter or drop security policies, their changes to the security policies can be audited. If you have special circumstances where highly privileged users, like a sysadmin or DB_owner, need to see all rows to troubleshoot or validate data, you would still have to write the security policy in order to allow that. If you have created a security policy where schema binding equals off, in order to query the target table, the user must have the select or execute permission on the predicate function. They also need permissions to any additional tables, views, or functions used within the predicate function. If a security policy is created with schema binding equals on, the default, then these permission checks are bypassed when users query the target table. Best practices. There are some best practices to take in mind when you want to implement RLS. We recommended creating a separate schema for the RLS objects. RLS objects in this context would be the predicate functions and security policies. Why is that a best practice? It helps to separate the permissions that are required on these special objects from the target tables. In addition to that, separation for different policies and predicate functions may be needed in multi-tenant databases. However, it is not a standard for every case. Another best practice to bear in mind is that the alter any security policy permission should only be intended for highly privileged users, such as a security policy manager. The security policy manager should not require select permission on the tables they protect. In order to avoid potential runtime errors, you should take into mind type conversions and predicate functions that you write. Also, you should try to avoid recursion in predicate functions. The reason for this is to avoid performance degradation. Even though the query optimizer will try to detect the direct recursions, there is no guarantee to find the indirect recursions. With indirect recursion, we mean where a second function calls the predicate function. It would also be recommended to avoid the use of excessive table joins in predicate functions. This would maximize performance. Generally speaking, when it comes to the logic of predicates, you should try to avoid logic that depends on session-specific set options. Even though this is highly unlikely to be used in practical applications, predicate functions whose logic depends on certain session-specific set options can leak information if users are able to execute arbitrary queries. For example, a predicate function that implicitly converts a string to datetime could filter different rows based on the set date format option for the current session. Next unit, exercise, manage authorization through column and row level security. Continue. Need help? See our troubleshooting guide or provide specific feedback by reporting an issue. Manage sensitive data with dynamic data masking. Completed 100 XP. 8 minutes. Azure SQL Database, Azure SQL Managed Instance, and Azure Synapse Analytics support dynamic data masking. Dynamic data masking ensures limited data exposure to non-privileged users, such that they can't see the data that is being masked. It also helps you in preventing unauthorized access to sensitive information that has minimal impact on the application layer. Dynamic data masking is a policy-based security feature. It will hide the sensitive data in a result set of a query that runs over designated database fields. Let's give you an example how it works. Let's say you work at a bank as a service representative in a call center. Due to compliance, any caller must identify themselves by providing several digits of their credit card number. In this scenario, the full credit card number shouldn't be fully exposed to the service representative in the call center. You can define a masking rule that masks all but the last 4 digits of a credit card number so that you would get a query that only gives as a result the last 4 digits of the credit card number. This is just one example that could be equally applied to a variety of personal data such that compliance isn't violated. For Azure Synapse Analytics, the way to set up a dynamic data masking policy is using PowerShell or the REST API. The configuration of the dynamic data masking policy can be done by the Azure SQL Database Admin, Server Admin, or SQL Security Manager roles. In Azure Synapse Analytics, you can find dynamic data masking here. Looking into dynamic data masking policies. SQL users excluded from dynamic data masking policies. The following SQL users or Microsoft Entra identities can get unmasked data in the SQL query results. Users with administrator privileges are always excluded from masking, and will see the original data without any mask. Masking rules. Masking rules are a set of rules that define the designated fields to be masked, including the masking function that is used. The designated fields can be defined using a database schema name, table name, and column name. Masking functions. Masking functions are a set of methods that control the exposure of data for different scenarios. Set up dynamic data masking for your database in Azure Synapse Analytics using PowerShell templates. In this part, we're going to look into dynamic data masking for a database in Azure Synapse Analytics using PowerShell templates. Data masking policies. Get a SQL database data masking policy. The Get a SQL database data masking policy gets the data masking policy for a database. The syntax for the Get a SQL database data masking policy in PowerShell is as follows. Copy. Get a SQL database data masking policy, serve. What the Get a SQL database data masking policy template does, is getting the data masking policy of an Azure SQL database. To use this template in PowerShell, you'd have to specify the following parameters to identify the database. Resource group name, name of the resource group you deployed the database in. Server name, SQL server name. Database name, name of the database. This template is also supported by the SQL Server Stretch Database service on Azure. Set a SQL database data masking policy. The Set a SQL database data masking policy sets data masking for a database. The syntax for the Set a SQL database data masking policy in PowerShell is as follows. Copy. Set a SQL database data masking. What the Set a SQL database data masking policy template does is setting the data masking policy for an Azure SQL database. To use this template in PowerShell, you'd have to specify the following parameters to identify the database. Resource group name, name of the resource group that you deployed the database in. Server name, SQL server name. Database name, name of the database. In addition, you'll need to set the data masking state parameter to specify whether data masking operations are enabled or disabled. If the template succeeds and the pass-through parameter is used, it will return an object describing the current data masking policy in addition to the database identifiers. Database identifiers can include resource group name, server name, and database name. This template is also supported by the SQL Server Stretch Database service on Azure. Data masking rules. Get a SQL database data masking rule. The get a SQL database data masking rule gets the data masking rules from a database. The syntax for the get a SQL database data masking rule in PowerShell is as follows. Copy. Get a SQL database data masking rule, schema name string, table name string, column name string, server name. What the get a SQL database data masking rule complete does it getting either a specific data masking rule or all of the data masking rules for an Azure SQL database. To use this complete in PowerShell, you'd have to specify the following parameters to identify the database. Resource group name, name of the resource group that you deploy the database in. Server name, SQL server name. Database name, name of the database. You'd also have to specify the ruleid parameter to specify which rule this complete returns. If you don't provide ruleid, all the data masking rules for that Azure SQL database are returned. This complete is also supported by the SQL Server Stretch Database service on Azure. New AS SQL Database Data Masking Rule. The new AS SQL Database Data Masking Rule creates a data masking rule for a database. The syntax for the new AS SQL Database Data Masking Rule in PowerShell is as what the new AS SQL Database Data Masking Rule complete does is creating a data masking rule for an Azure SQL database. To use this complete in PowerShell, you'd have to specify the following parameters to identify the rule. Resource group name, name of the resource group that you deploy the database in. Server name, SQL server name. Database name, name of the database. Providing the table name and column name is necessary in order to specify the target of the rule. The masking function parameter is necessary to define how the data is masked. If masking function has a value of number or text, you can specify the number from and number to parameters, for number masking, or the prefix size, replacement string, and suffix size for text masking. If the command succeeds and the pass-through parameter is used, the complete returns an object describing the data masking rule properties in addition to the rule identifiers. Rule identifiers can be, for example, resource group name, server name, database name, and rule ID. This complete is also supported by the SQL Server Stretch Database service on Azure. Remove AS SQL Database Data Masking Rule. The remove AS SQL Database Data Masking Rule removes a data masking rule from a database. The syntax for the remove AS SQL Database Data Masking Rule. What the remove AS SQL Database Data Masking Rule complete does, is it removes a specific data masking rule from an Azure SQL database. To use this complete in PowerShell, you'd have to specify the following parameters to identify the rule that needs to be removed. Resource group name, name of the resource group that you deploy the database in. Server name, SQL server name. Database name, name of the database. Ruleid, identifier of the rule. This complete is also supported by the SQL Server Stretch Database service on Azure. Set AS SQL Database Data Masking Rule. The set AS SQL Database Data Masking Rule sets the properties of a data masking rule for a database. The syntax for the set AS SQL Database Data Masking Rule in PowerShell is as follows. Copy. Set AS. What the set AS SQL Database Data Masking Rule complete does is setting a data masking rule for an Azure SQL database. To use this complete in PowerShell, you'd have to specify the following parameters to identify the rule. Resource group name, name of the resource group that you deploy the database in. Server name, SQL server name. Database name, name of the database. Ruleid, identifier of the rule. You can provide any of the parameters of schema name, table name, and column name to retarget the rule. Specify the masking function parameter to modify how the data is masked. If you specify a value of number or text for masking function, you can specify the number from and number to parameters for number masking or the prefix size, replacement string, and suffix size parameters for text masking. If the command succeeds, and if you specify the pass-through parameter, the complete returns an object that describes the data masking rule properties and the rule identifiers. Rule identifiers can be resource group name, server name, database name, and ruleid. This complete is also supported by the SQL Server Stretch Database service on Azure. Set up dynamic data masking for your database in Azure Synapse Analytics using the REST API. For setting up dynamic data masking in Azure Synapse Analytics, you can also make use of the REST API. It will enable you to programmatically manage data masking policy and rules. The REST API will support the following operations. Data masking policies. Create or update. The create or update masking policy using the REST API will create or update a database data masking policy. In HTTP, the following request can be made. Greater than note, the date of the API will change over time and the version you use will be determined by your needs and the functionality record. HTTP copy. Get https://management.azure.com/subscriptions/subscription. The following parameters need to be passed through. Subscription ID, the ID of the subscription. Resource group name, name of the resource group that you deployed the database in. Server name, SQL server name. Database name, name of the database. Data masking policy name, the name of the data masking policy. API version, version of the API that is used. GET. The GET policy gets a database data masking policy. In HTTP, the following request can be made. HTTP copy. Get https://management.azure.com/subscriptions/subscription/resource group name. The following parameters need to be passed through. Subscription ID, the ID of the subscription. Resource group name, name of the resource group that you deployed the database in. Server name, SQL server name. Database name, name of the database. Data masking policy name, the name of the data masking policy. API version, version of the API that is used. Data masking rules. Create or update. The create or update masking rule creates or updates a database data masking rule. In HTTP, the following request can be made. HTTP copy. Put The following parameters need to be passed through. Subscription ID, the ID of the subscription. Resource group name, name of the resource group that you deployed the database in. Server name, SQL server name. Database name, name of the database. Data masking policy name, the name of the data masking policy. Data masking rule name, the name of the rule for data masking. API version, version of the API that is used. List by database. The list by database request gets a list of database data masking rules. In HTTP, the following request can be made. HTTP copy. Get. The following parameters need to be passed through. Subscription ID, the ID of the subscription. Resource group name, name of the resource group that you deployed the database in. Server name, SQL server name. Database name, name of the database. Data masking policy name, the name of the data masking policy. API version, version of the API that is used. Next unit, implement encryption in Azure Synapse Analytics. Continue. Need help? See our troubleshooting guide or provide specific feedback by reporting an issue. Implement encryption in Azure Synapse Analytics. Completed 100 XP. 3 minutes. In this section, we will go through transparent data encryption and token library for Apache Spark. What is transparent data encryption? Transparent data encryption, TDE, is an encryption mechanism to help you protect Azure Synapse Analytics. It will protect Azure Synapse Analytics against threats of malicious offline activity. The way TDE will do so is by encrypting data at rest. TDE performs real-time encryption as well as decryption of the database, associated backups, and transaction log files at rest without you having to make changes to the application. In order to use TDE for Azure Synapse Analytics, you will have to manually enable it. What TDE does is performing I/O encryption and decryption of data at the page level in real time. When a page is read into memory, it is decrypted. It is encrypted before writing it to disk. TDE encrypts the entire database storage using a symmetric key called a database encryption key, DEC. When you start up a database, the encrypted database encryption key is decrypted. The DEC will then be used for decryption and re-encryption of the database files in the SQL Server database engine. The DEC is protected by the Transparent Data Encryption Protector. This protector can be either a service-managed certificated, which is referred to as service-managed transparent data encryption, or an asymmetric key that is stored in Azure Key Vault, customer-managed transparent data encryption. What is important to understand is that for Azure Synapse Analytics, this TDE protector is set on the server level. There it is inherited by all the databases that are attached or aligned to that server. The term server refers both to server and instance. Service-managed transparent data encryption. As stated above, the DEC that is protected by the Transparent Encryption Protector can be service-managed certificates, which we call service-managed TDE. When you look in Azure, that default setting means that the DEC is protected by a built-in certificate unique for each server with encryption algorithm ISE 256. When a database is in a geo-replicated relationship, then primary and the geo-secondary database are protected by the primary database's parent server key. If the databases are connected to the same server, they will also have the same built-in ISE 256 certificate. As Microsoft, we automatically rotate the certificates in compliance with the internal security policy. The root key is protected by a Microsoft internal secret store. Microsoft also seamlessly moves and manages the keys as needed for geo-replication and restores. Transparent data encryption with bring your own key for customer managed transparent data encryption. As stated above, the DEC that is protected by the transparent data encryption protector can also be customer managed by bringing an asymmetric key that is stored in Azure Key Vault, customer managed transparent data encryption. This is also referred to as bring your own key, BYOK, support for TDE. When this is the scenario that is applicable to you, the TDE protector that encrypts the DEC is a customer managed asymmetric key. It is stored in your own and managed Azure Key Vault. Azure Key Vault is Azure's cloud-based external key management system. This managed key never leaves the Key Vault. The TDE protector can be generated by the Key Vault. Another option is to transfer the TDE protector to the Key Vault from, for example, an on-premise hardware security module, HSM, device. Azure Synapse Analytics needs to be granted permissions to the customer-owned Key Vault in order to decrypt and encrypt the DEC. If permissions of the server to the Key Vault are revoked, a database will be inaccessible, and all data is encrypted. By using Azure Key Vault integration for TDE, you have control over the key management tasks such as key rotations, key backups, and key permissions. It also enables you to audit and report on all the TDE protectors when using the Azure Key Vault functionality. The reason for using Key Vault is that it provides you with a central key management system where tightly monitored HSMs are leveraged. It also enables you to separate duties of management of keys and data in order to meet compliance with security policies. Manage transparent data encryption in the Azure portal. For Azure Synapse Analytics, you can manage TDE for the database in the Azure portal after you've signed in with the Azure Administrator or Contributor account. The TDE settings can be found under your user database. It is by default that the service managed TDE is used, and therefore a TDE certificate is automatically generated for the server that contains that database. Moving a transparent data encryption protected database. In some use cases you need to move a database that is protected with TDE. Within Azure, there is no need to decrypt the databases. The TDE settings on the source database or primary database will be inherited on the target. Some of the operations within Azure that inherited the TDE are Geo Restore, Self-Service Point-in-Time Restore, Restoration of a deleted database, Active Geo Replication, Creation of a database copy, Restore of backup file to Azure SQL Managed Instance. If you export a TDE protected database, the exported content is not encrypted. This will be stored in an unencrypted backpack file. You need to make sure that you protect this backpack file and enable TDE as soon as the import of the backpack file in the new database is finished. Securing your credentials through linked services with Token Library for Apache Spark. It is quite a common pattern to access data from external sources. Unless the external data source allows anonymous access, it is highly likely that you need to secure your connection with a credential, secret, or connection string. Within Azure Synapse Analytics, the integration process is simplified by providing linked services. Doing so, the connection details can be stored in the linked service or in Azure Key Vault. If the linked service is created, Apache Spark can reference the linked service to apply the connection information in your code. When you want to access files from the Azure Data Lake Storage Gen 2 within your Azure Synapse Analytics workspace, it uses AAD pass-through for the authentication. Therefore, there is no need to use Token Library. However, to connect to other linked services, you are enabled to make a direct call to the Token Library. An example can be found below. In order to connect to other linked services, you are enabled to make a direct call to Token Library by retrieving the connection string. In order to retrieve the connection string, use the getConnectionString function and pass in the linked service name. Scala copy, //. If you want to get the connection string as map and parse specific values from a key in the connection string, you can find an example below. To parse specific values from a key equals value pair in the connection string such as default endpoints protocol equals HTTPS, account name equals account name, account key equals account key. Use the getConnectionString as map function and pass the key to return the value. Scala copy, // linked services. Next unit. Continue. Need help?